And then
Okay.
above him is Jerry.
Okay.
I think he's going to be very.
He's the new boss.
Yeah.
Yeah. Jerry. Lee and Jerry. Okay, very good. Yeah, I'll see you tomorrow night.
Okay.
I brought my wife. She's here too.
Oh, she is.
I told her that. Yeah, tomorrow I'm going to be very unavailable all day.
Yeah. Is she going to come to Bangkok?
No. So this was our plan. She loves Bangkok. We were going to do this trip, and then we were going to leave this weekend for Bangkok because there's a meeting there that I have a paper that was accepted, and I have to travel for and everything. But I'm not going to go now because it was just too long. And even right now, she's in the hotel. She feels like hell. She just, you know, her health issues. So she's just been in bed all day. So we're really glad we didn't do that because we were going to be gone for 3 weeks. We're not doing that. So, but she wanted to go to Bangkok. But I talked to Gunther, and it was a good point because I looked it up since then. She really likes to go to Chiang Mai for like the elephants and.
Yeah.
But during that time of the year, unfortunately, is where they have all the they burn everything up north, and they said it. Gunther said, and I confirmed in my mind that it's just a horrible time to go there. The air quality is horrible, and so we're like, ah. So she probably won't go.
We're going to go. Tracy's going, but we're going to go south.
That's probably exactly. That's probably the way to go.
Yeah. Yeah. There's a forget the name of it, but there's a big conservation park.
Oh, really?
that
That's
is,
so.
More complicated than that.
Beautiful.
We need to contact the secretariat.
Yeah, that's cool. I may be able to keep it.
Sont au rez-de-chaussée.
Okay.
Qu'est-ce qui
That's gorgeous. So it's on the ocean.
Yeah.
Yeah, that's
Well, no, it's like lakes.
the lakes. Okay, so it's not all the way south, like
No.
Phuket or whatever.
No.
Okay,
No, apparently Phuket, according to Gunther, is not so good.
that's what he told me too. Yeah, he said it was. Yeah, that's what exactly he told me. He said it's
So
a
is there
Russian.
something wrong with Russians?
Yeah,
I've
it's-
seen
Celui qui doit commencer. Non. On le met à la
Hi, Luigi. Can you hear me?
But
All right, I'll catch you.
oh yeah.
Yes, Damien.
Hey, hello, everyone.
Tu vois, sinon je descends et tu fais la présentation des slides. Là, c'est le oh, par mail. Mais je ne sais pas c'est quoi. Non plus. Mais bon. On peut le mettre à la fin. Ça vous dit ça? Okay. Yeah. Let me go back. So, hello everyone. So we are starting a couple of minutes late with the LISP working group session. As usual, the first slide is the note well. You are supposed to be familiar with this. You signed on this while registering for the IETF. The first one basically says everything we exchange here in this room is a contribution to the IETF, and IPR rules apply. And there is also the code of conduct that applies here. So we are here to talk about technology, even if we disagree, we respect each other. Okay. Usual tips, as you know, you are in the room, you have to log on the Mitico tool with the on-site tool. If you are remote and you are listening, you already know that you have to use the full client. These are the usual pointers. Quick update on the status compared to 120 in summer. So we have a few documents that are on the agenda, namely the multicast document, the Young model, and later on, Damian will present the 8111 bis document, and we have a new proposal for the LISP in Savvy context. A few things, we think that the LISP geo coordinates is ready to go forward. We had the okay of the Sheffer, so we will issue the working group last call, okay, this week. Concerning the LISP name encoding, this document is under IESG evaluation, and there is a discuss from the one of the security ADs. Now, Dino, which is the main author of this document, doesn't have really the time to address this. And we are looking for anyone that wants to volunteer to take the editorship of the document and just fix the editorial issues, because at the end of the day are editorial issues in order to address the discuss of the security ID. So if anyone wants to do it, please talk to the chairs, me and Padma. Okay. Padma just finished the Sheffer's review for the LISP traffic engineering. You want to say the status of this one?
So the list status on this document is we have done a thorough code review, a thorough review of the document. We actually added a lot of clarifications on processing of the S and L bits. And for now, I think all the comments have been addressed and the document is ready for last call.
And last thing, there is the reliable transport, the blame on me. We are a bit late, but there was an action point that I missed. I have to review the IANA section, and then I think we are ready for that one. Now, agenda. Dino has a small issue in connecting, but I have one-time token for him. I'll forward to him right now, live. But what I propose is to do some agenda bashing. So actually, Damian, you are there?
Yeah, tell me. Yeah, I'm listening.
Yeah, maybe you can start the session. We will do then the Savvy network, and then we do the Young and the multicast document.
Okay, yeah, I can start. You can just show the slide and I can start.
Okay. You see the slides?
Yeah. So hi everyone. So I'm presenting the new version of the LISP DTT document. The objective is to go to standard in this case. Next slide.
Actually, you have the control. You can try to.
I have the control. Okay, yeah, okay. Yeah, I have the control. So you have seen that we have two versions. It's actually we had some typo in the name of the document, so we had to resubmit it to have the correct naming. So no big deal, no difference between them beside the name. Mostly the structure isn't changed. What we did is we removed the DTT map request because it's done in RFC 9301. And since the very last version, there is also some deployment experience. So we added the section of deployment experience. It will need to be added, actually, the content. There is a section, but no content. Well, we also updated the IANA section to conform with the new guidelines of how to basically write them. So everything is there on the screen. And we need to define the DTT referral cache. So now, one important thing that we have noticed while we writing the document, preparing the document, is that there is an inconsistent definition of the instance ID. So officially, the instance ID is a 24-bit value. But if you look in this particular document or in the previous document, the XEID assumes that it's 32 bits, not 24. So we propose to have two types of update. Let's say it's either because actually it's not sent on the wire, it's just in the implementation. It's just a way to have a key in the database. So it's either we say that the IID is 24 bits and up to all the implementations or the current implementation to do the padding themselves, but it's transparent. So it's just like, okay, it's 24 bits. Or we can say, okay, there is explicitly say it's still 32 bits, except that you have 8 bits of padding set as 0 and 24 bits that correspond to the IID. That's up to the group to decide what would be the best. So as I said, the IANA consideration has been updated as well as the new references. So there is the standard main specification that have been put correctly according to the latest version that exists. So there are many next steps. We have to be sure that there is no residual text about routing scalability. So it's not the purpose anymore. It would be really nice to have people that revise the pseudocode and the examples. And maybe to clean up a little bit. Maybe they are not all necessary. Sometimes there are some pseudocode that might, it's not really needed. Of course, the point that I just rose was the XEID format. So do I take the cursor now or we keep it for later, Luigi?
As you like.
I prefer so for later. We take it later, okay? So then we have all the questions and things. We still have to define what is the DTT referral cache. Of course, we have to read everything. And there is something, it's not, I forgot to have the bullet here, but actually, if you look, there is the signature algorithm. And for the moment, there are only two of them. It's basically RSA. One is deprecated and the other one is RSA 256. Probably it would be good to propose other algorithms because RSA, according to me, should not be used anymore if we can do elliptic curves or these kind of things, for example. And maybe we could, it's an 8-bit that is assigned for the value of the signature algorithm. Maybe we should synchronize with the different standard that already exists to mention which algorithm it's which, because for now it's 1, 2, 3, 4, but probably there is already some standard about it. So that's it for me. So yeah, Mark.
Hi, thanks, Mark with Cisco. With respect to the 32 bits and 24 bits, as far as I remember, instance ID it's supposed to be 32 bits. The 24-bit restriction is when you plan to use it in the data plane, right? For segmentation, but at control plane we can still use the full 32-bit range for other use cases that do not map to data plane segments. So just I don't know. Maybe others can comment. May not have the whole context, but
actually, it's slightly more complicated. There was this situation, as you said. Sorry, Luigi speaking. Then during the last call and security reviews, etc., the review was this is inconsistent. So if you look at the 9301, it's 24 bits everywhere.
Oh, okay, I missed it. Okay.
And I mean, I don't have strong opinion, but since on the wire is always 24 bits to align, so first of all, to align for with the existing specification, IID should be 24 bits.
Okay.
Now the extended DID prefix, should we put there 8 bits padding or not? I mean, since it's not on the wire, doesn't really make sense to me. Personal opinion. What we can do is explain the situation in an appendix of the new document. If anybody has the question why before was 32, now is 24. But yeah, it's just an option.
Yeah, sounds reasonable. Yeah. Yeah, that was it. Yeah, I just wanted to pitch on the 32 versus 25.
Okay, thanks, Mark. Any other question?
Do we have, Damien speaking, do we have someone that would be okay to look at the SIG algorithm, to look that it's compliant with the current security recommendations and cryptography recommendations? An expert on that?
Maybe we can ask a review from the security directorate, to ask someone to look at the security aspects of this document as an ad hoc review now. Would that make sense for you, Damien?
Yeah, Damien speaking. Yeah, that would be perfect.
Okay.
And maybe they would say that for the purpose of that we have RSA 256 is okay, but I think no.
Okay. Okay, if there are no further questions, I propose, Mark, you go next with the Savvy document, and then we switch to Dino.
Okay.
Switch. These are yours. There we go. You have also the control of the slides now.
Okay, correct. Okay, so I'm presenting this, Mark Vesiska. I'm presenting this new draft that we submitted for consideration for the working group. This is, title is Savvy in a LISP Network. Presenting, and these are Lakshmi, Radko, the other co-authors of this draft. So the motivation for this draft is what we wanted to do is document the use of Savvy procedures when running a LISP network. And the use of these Savvy procedures is to provide source address protection when providing IP address distribution in the LISP network, and this would apply both for IPv4 and IPv6. If you are not familiar with it, Savvy is this source address validation improvement. I think this was a working group that concluded some years back with 6 RFCs, and it's a proposed standard. And what it brings is that it provides a very generic solution for source address validation, or they also call it source guard, that applies equally for IPv4, IPv6, and it gives support for DHCP, SLAC, and I don't know. It also combines with static addresses, link local addresses, this kind of thing. Okay. A little bit more introduction into Savvy is that the interesting thing about Savvy is that it validates IP addresses by tracking how they are assigned to endpoints. In essence, what it does is it binds addresses to specific anchors. A MAC address of an endpoint is the typical anchor that they use, right? And in the Savvy working group, they documented two main strategies for validation. One was by considering DHCP assignment as some sort of authority, right? And then what they do is they track these DHCP assignments while the endpoint is alive in the network, and this is documented in RFC 7513. And the other strategy is the first come, first serve, right? This idea that the first time this IP is seen on the network, a binding is created for this IP address, and then the purpose of the Savvy agent is to track this binding and make sure that it stays as is. Okay, and that's the other draft. The whole story with Savvy is that it scales by distributing these binding tables or binding database across switches in the network, and the whole thing that is specified in the specs is that Savvy keeps these binding state. So for each IP address, it always has a binding state. You can consider this some sort of state machine where it says, okay, the IP address is valid, is not valid. I'm testing whether it's still okay or not. Okay, so what we wanted to do with this graph is say, if you take the Savvy specifications, you take LISP specifications, Savvy can operate over a LISP network without any change, as long as the LISP network is able to extend L2, like we document in the mobility draft. The only thing that Savvy requires is L2 flooding or replication between all the edges, let's say, or XTRs. And the one caveat that it has is that it may take a while for Savvy to figure out things, right? So for example, when IP is detected, Savvy has all these procedures where it broadcasts some packet, it waits for a timeout, it tries to decide whether this IP address is genuine or not, right? And the same happens with mobility, the same happens with IPsec cases, okay? What we observed is that we are able to offer a tighter integration with LISP, Savvy and LISP, right? And this allows us to optimize some things, right? And I'll talk about them, but the good thing is that, okay, by this tighter integration, things happen a little bit faster, right? And you don't need to flood as much, for example. But you can still be conformant with the Savvy procedure. Okay, so very briefly, I'll just wanted to motivate a little bit the drafts. I'll let you guys read if you're interested. Just will point a couple of things about this integration. The first thing is that this is how the draft proposes that Savvy runs in a LISP network. The idea is that in Savvy you have to define a perimeter, right? Wherever it's outside the perimeter, you need to be, or Savvy is going to provide this source address validation. Wherever it's inside, it's considered your trusted trusted domain. Okay. So with this perspective, what we do is we place the Savvy agents on the XTRs, right? And we consider if you want the RLOC space as our trusted perimeter, and the EID is what we need to protect. Right? And just as an example, this is how more or less it works. For example, this is the case where we are onboarding an EID, right? So This is following the first come first serve Savvy specification. What we would do is something like this, right? We see traffic, or the Savvy XDR would see traffic. We say, okay, this IP, it's a candidate IP that I want to onboard in my network. And what the Savvy XDR I don't know, line in the picture does, it exemplifies how we are transitioning through the binding state, the binding state, or the binding state machine in as specified in the Savvy RFC. Okay, if you see the Savvy specification starts with this no binding, then moves the IP address into some tentative state, and finally moves to valid state. What the specification proposes is once it moves to valid, LISP can onboard it and register with the network. Some things that the document goes through is how the state machine is linked to LISP signaling. For example, when Savvy discovers this IP and wants to validate it, the first thing that it can do is query the map server, LISP map request, and check whether this IP is discovered anywhere else. Right? If it's not, then it goes through regular Savvy procedures to decide, oh, wait, looks like I can onboard this IP because it's not seen anywhere else. Right? I'm not going too much into detail. I'll leave you guys if you're interested, but just wanted to use this as an example, and similar examples we can do with EID mobility, IP theft prevention, and also special provisioning for fast roaming. But the whole idea here is that since we have in the LISP database on the mapping system all the IPs that we have discovered every time, and a location for these IPs, right? This can help us optimize Savvy procedures so that things run faster, right? And at the same time, Savvy is giving the LISP network this source protection. The current spec that we submitted focuses in the first come first serve Savvy. We can do similar things with DHCP. The state machine changes a little bit, but the basic principles are the same. And just as a final note, yeah, we just uploaded version 0.0. It's a new one. We were wondering, or I'll leave you guys to give an opinion, but whether this could be interesting for the working group. And one interesting note is that we have been running this in production for a while, right? So we are documenting this based on practical experience. And that's it. See, there is a question in the line.
I suppose invited speaker should be Dino. So Dino.
Yeah, hi, can you hear me?
Yes?
Yep.
Yeah.
I did.
Okay. Mark, it seems to me that this actually duplicates functionality that LISP already has when you're doing EID mobility, because the EID mobility draft definitely validates the source EID against a configured list of, quote, roamable EID prefixes. So, and I assume that the Savvy is done just for EID type addresses and not RLOC addresses. Reaction?
Yeah, it's just for EID addresses. In terms of duplicating, partially, yeah. I would say what it brings also is things like, for example, duplicate address detection, that we don't have anything explicit in that draft, right? Or for example, IP theft protection. If there's a duplicate, how do I decide which one is the valid one, which one it's not, right?
I think in the EID draft, we said that first come, first serve to the mapping system. So
yeah,
if I was doing
sorry.
an EID, the XTR that sees my packet could drop packets while it's validating that there's nobody else there. Now, of course, that guy can move and he can be deregistered, so the spoofer could actually sneak in. So, but the spoofer also needs some there. I guess if the spoofer's not running Lisp, it doesn't need a key. It's depending on a trusted XTR to that has the keys to the mapping system. So it's not really a reliable mechanism, right?
Yeah, I think so. I mean, it helps us because it provides kind of a framework where multiple use cases were considered. For example, one good one here is also the HCP, right? That it's also kind of a external trusted source that we integrate via Savvy to the whole network. But I propose that if you have time, just take a read what the document says, and maybe we can sit together and see where it collides with the ID mobility and
Sure,
yeah.
no problem. One other really quick comment. Is
Yeah.
this going to add mobility latency or handoff latency to moving EIDs?
Yeah, so this is kind of a trade-off with Savvy, right? Is protection and speed, right? In the draft, we propose one section we call fast roaming, right? Where it kind of gives the option to do quick onboarding and then correct after the fact, for example, if there is IP collision. But yeah, I mean, depending on the level of trust that you want to bring, it definitely has an impact on the speed because yeah, you want to constantly validate whether things are good or not.
Okay. You
Yeah,
have a
I have a question. Hey, I have a question on this. Imagine the case where you have somebody who is legitimate that goes away. I think Dino alluded on that as well, is somebody sneaking in. I
Mhm.
was wondering, how do you reclaim your IP address if somebody is already taken it? Because from what I looked at, the algorithm is the first one who claims it that stays there. So reading the document, I felt like we need to write a little bit more about this, how to handle this case.
Yeah, it's a good point. I would say, in some sense, this is where we rely on the work that the Savvy working group did. And I think that's where the working group banks on this anchor idea, right? So what the draft does is yeah, this story, right? I mean, it anchors this IP to, or binds this IP to anchor, and the anchor is supposed to not change, right? But yeah, it has some limitations, and especially in the first come first serve model, as you say, right? If someone goes away and someone else comes and claims, the problem that you will have is that IP won't collide with anybody, and the new guy can claim it. That changes a little bit with the DHCP model. It's a bit more protected in this sense. But yeah, you're right. We can try to explore whether Savvy considered this case, but I think one caveat of the first come first serve model is exactly what you say. What it protects is that no one uses it as long as you are active. If you go away, you are subject to losing your ID.
I was really thinking on the case where you lock out someone on purpose. So maybe, that might be of interest to look at.
Okay,
I have
okay.
a second question on this one as well. I was wondering, when we were talking about mobility, we're also talking about anonymous CID. How will this work if we have anonymous CIDs, and have you look at the interaction between those two?
I'm sorry, which EID? I couldn't. Interaction with what type of EID? Sorry.
So I'll follow up online with you then on that one. Okay.
Oh, okay. Sorry, I couldn't. My audio, right?
Dino, you have another quick comment?
Yeah, I do. Is there any provision in Savvy to have a one-to-many anchor point binding? Because this happens to me all the time. I'm in a coffee shop and I'm connected to one Wi-Fi, and then I may go ahead and switch to another Wi-Fi on another physical interface, and that means there's two MAC addresses that would be associated with my one EID. Will that be able to work, Mark?
Actually, okay, so I haven't seen a specific provision in the Savvy documents, but also nothing not allowing you to do that. So, for example, in our implementation, we do hold multiple bindings to same anchor, right? Same MAC.
That's in the wrong direction. That you said it in the opposite direction. You said multiple EIDs to one MAC. I'm saying I have one ID and I'm roaming around, and I may have different MACs because I use different interfaces.
With the same EID. Yeah,
Correct.
I think that won't work, right? Because you would have multiple anchors for the same IP.
Address.
Yeah,
Yeah.
I don't think Savvy is ready for that. Yeah.
Okay. Okay.
Mm-hmm.
Okay, let's better move forward. Mark, I invite you to send a message on the mailing list because this document has been uploaded after the cutoff date when the system opened again. So it would be good to send it on the mailing list so that people can comment on the content. And if you have a specific points on which you want a feedback, put it also on the email. Okay.
Okay. Yeah, I'll do that. Thank you.
Okay, Dino, I hand it to you. I'll share the slide.
Okay. Wonderful. Can you hear me?
Control the slides now with the arrow keys in principle.
You're going to control, or do I?
You can.
Okay. 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 I'm just going to give an update on the LISP multicast documents, the standards track, and one working group document. This is just a follow-on from the last IETF. So it's pretty short presentation. So we started with RFC 6831, which was published in January 2013 with the original set of experimental RFCs. What we did in May was we decided to put this on standards track for proposed standard, and we created an individual contribution and called it 6831 BIS. And then last IETF, we decided to make it a working group. So now it's an official draft IETF LISP RFC 6831 BIS. And that's tagged there, as you can see, as a proposed standard. We did the same with 8378, which is the signal-free multicast address. So it followed sort of the same destiny as 6831. Okay. So we had this one other document that has some really good design in it, and it allows us to create the underlay group, and we called that group mapping. It was an individual contribution started in May of this year. It went through many individual contribution changes, but the VDAS stands for Venkat, Dino, Ashwin, and Stig, who are the co-authors. The working group accepted that in September, so we have it as an official working group. I call this document with the other two documents the set of three, because it creates this logical architectural set on how you do multicast. And the important thing to note, so we don't slow down the standardization of 6831 bis and 8378 bis, is that those documents do not point to this group mapping because it's not following the same standardization status. The group mapping draft does point back, obviously, to these two. So it's really a unidirectional reference. And so at this time, I'd just like to request we go last call for all three of them, and to have the destiny of the group mapping draft to be experimental, if that's possible. It doesn't have to be. I mean, it's probably way too early to make it standards track, but so you could still run 6831 bis and 8378 bis without the underlay mappings, because they both use the mapping system or PIM or local configuration to decide what the underlay group address is. Okay, so just a very quick, this is probably the third or fourth time I've presented this, but what's the difference between 6831 and 8378? Very simple. 6831 uses signaling, meaning it uses the underlay PIM infrastructure to join and build PIM distribution trees between XTRs. And in 8378, we don't use PIM. We use the mapping system to find out where ETRs to encapsulate to. And so in 8378, you can actually encapsulate to unicast RLOCs or even multicast RLOCs if they're registered in a mapping system. We changed 6831 to allow unicast RLOCs as well. So they both have the option of doing unicast RLOCs versus multicast RLOCs. And we believe there's no, I mean, Venkat could, or Prasad could, or Stig can verify. I think you can put a unicast address in the group field of a PIN message to signal across. I'm not sure about that, but there may be new join attributes that allow that to happen. So the group mapping draft is pretty simple. There's two ways to map to an underlay group address. You can hash to it. That's the first one. The overlay, the GRLOC is hashed by all the XTRs, and they could do it independently because the hash function is published. Or they can use the mapping system, and that's where the group address could be associated, so everybody rendezvous to the same group address. And the first is important if you want decentralization, and the second's important if the underlay provider wants control of what group addresses are used. So the first one is hash-based, and the second one's mapping system-based. So that's it for the set of three. I just wanted to give a brief update. We had a lot more documents that I co-authored at last IETF, and we let many of them time out, and a lot of them were moved, like these BIS documents were moved to working group. So these are the last three that are that I'm responsible for. The Lispers.net NAT draft is still waiting in the ISC review for the working group to decide what the status of NAT is in the working group, and didn't know what to do with the decent draft. It's a mapping system that works really well, and I have a lot of empirical data on how it scales. But it turns out that the latest charter of the working group doesn't allow for new mapping systems to be created. So now this document that existed when it was in the charter now is out of the charter. So I don't know if we should make that informational or make it a working group document, but it's been around for quite a long time. It's been around since, I think, 2018. And so I keep updating it every 6 months so it doesn't time out. And the LISP satellite network draft is basically just a use case document and how LISP works without any protocol changes when the underlay network is a satellite network. And it's pretty well documented. Padma's co-author with me on that, among others. So I'll leave this to the working group to decide what happens here. I talked to Ellie at the ISC about making decent informational RC, and he wasn't against that, but he wanted the working group. He wanted the blessing from the working group to decide what to do. I think that's it.
Anyone has any comment?
Yes. So,
Prasad.
yeah, this is Prasad. Yeah, thank you. So, Dino, yes, you're right, Dino, that, we can signal the underlay multicast group using the join prune attributes. So, you're right on that.
Okay, great. Thanks for confirming.
Yeah. Second point, you talked about the VDAS becoming experimental. To be very honest, that's a very good idea. I wholeheartedly agree. I just have one suggestion though. If we split the hashing part, the VDAS, as you put in the previous slide, has two parts. One is the hash based, and then the other is the mapping. The mapping system based, right? Maybe the hash based is reasonably okay to become part of the standards track. I don't know how we can do that. I mean, maybe if we can just think about kind of making two documents or making the hash based as part of the 8378. I don't know. I'm just speculating.
Yeah, it's a really good point because the hash base can be run independently.
Exactly.
And even an implementation could do it without a specification. I mean, you have to specify what the hash is and what the signature data is that you hash over. So it could go separately. Now with the mapping system one, it is a two-step process because you're encoding the group name in a distinguished name, right? And so that depends on another draft, but that draft's moving along as well. So it's not a problem. So I have no opinion of what to do if you want to split it or whatever.
Okay. Maybe we'll take it offline and kind of conclude how to take it forward.
Okay, thanks.
And the third point, sorry, one last point. The third point is the 6813 is very well implemented. Multiple implementations in production with V4 underlay, with V6 underlay, head-end replication. And the biggest addition since 6813 happened as an RFC was that we have included the ingress replication part, which has also been implemented in production. So just a data point so that there are pretty stable implementations running in production, large production networks for many years now.
And are you making that claim for 6831 as well as 8378? Or
no, only for 6831. Only for 6831.
So you do the PIM-based signaling implementation, and does Cisco have a signal-free implementation as well?
Well, it's not yet released, so we don't have a released version.
Okay, that's good to know, though.
Yeah.
And the my Lispers.net implementation only does 8378. So that's maybe not a good thing.
Thank you, Prasad. Alberto?
Hey, this is Alberto Rodriguez from Cisco. Hey, Dino, thanks a lot for the presentation. Love to see you even if in the screen. I have one comment on the remaining documents that you mentioned in your last slide, particularly on the LISP satellite one. I think that makes sense having an informational around that use case, but I would like to point out that we have other two use case documents that have been hanging around for a while, the ground-based LISP and the Hexagon one that cover the use case for civil aviation and the case for connected vehicles and so on. I would like to see if we have a common approach for those documents. So if we say that we may go through informational via ISC, that's okay. But I would suggest that we take those, the three of them can follow the same process. I don't know if the chats have any opinion on that.
As far as I remember, one of the last milestones is to have a use case document that documents informational and documents the how we can use LISP for things that are not necessarily the first objective of LISP when it has been designed. So document like this one, the satellite, or you say the Nexagon, can be merged somehow together and give short snapshot of the use cases and maybe the details in the annex part, appendix part of the document, just not to make big parts. I mean, this is one option, or we can keep it separate. I don't know, but we can discuss on the.
Yeah. I mean, we have discussed this in the past.
I guess you have to ask the question, merging 2 or 3 20-page documents, is that a good idea?
That's why I'm suggesting to keep the part when Alberto say a common approach, and this is the main part of the document, and then the rest, the details, can be the appendixes of the document. So when someone is really interested, then he can go deeper.
So
but
just
something that we can consider and discuss. I mean,
just to be clear, when I say common approach, what I mean is common process, so same procedure for the three. Without any hat on, my personal preference would be to have separate documents so that they are more readable. But when I mean common approach, I mean like the process that we follow. But we can
The
discuss this.
IETF process.
it's up to
that we
discussion.
follow.
I mean,
Yeah.
personally, I don't have a strong position on this. But,
all right.
You have something on the satellites, but
no, as a co-author, I will defer to you as a co-author.
I have a company. So on the NAT document, I discussed with Elliot earlier, the independent mission editor, and is just waiting for us to resurrect the NAT document so that we have the NAT document here, and then he can make a review and assessment on the your document, the LISP NAT traversal. We will do it. The plan is to work again with Damien also on the NAT document and then move it forward. This will come hopefully before the end of the year. As for the decent, as far as I remember, this is that document that went through 2 adoption calls and didn't make it.
Yes.
And now it's out of the charter, as you say. So if Elliot is happy to publish in the independence team, go for it. I mean, at some point he will come back to us, me and Padma, to have a review. We'll give it, and the document can progress.
So is it okay if I ask the ISC that the chairs are okay for it to be informational? Is that what you're?
You can say it so, but anyway, he will come back to us to have a formal review.
Okay.
But go ahead.
Okay.
Right, Padma.
Yeah, I agree on that.
Okay. And as for the last call for the multicast documents, we discussed with Padma and Alberto as well. In order to be in line with the procedure, what we're gonna do is to review the documents, not only us, also other person that volunteers. And after that, we have a first wave of review. We will consider the fact that going for last call. I mean, if there is anything to address, we will address it together. Otherwise, we will move it forward as quickly as we can. Okay.
Okay. Thank you.
Okay. Thank you very much, Dino. Alberto, you an update on the young update. Here we go. You can try with this. I can put it. Wait. I need the USB key. I didn't plug it. Otherwise, you just say next.
Okay. Okay. So this is Alberto Rodriguez Francisco again. Just a quick update on the Jan document. This was, we presented a summary of the open items. I don't know if it was the last IETF or the one before, and this is hopefully addressing all that. So if you want to go next. So just to recap, I'm not going to go through this. So there are 3 slides here. If you want to press forward twice again, this is what was presented in the last IDF, the one before. And these are the comments we got. You have the link to the mailing list to get all the details if you want to check that, and just pasting the slides here for convenience. So next. Now, what we have updated for 22. I have broken the update down in like, I think 4 sections from more relevant to less, and I'm just gonna quickly summarize things, but the details are on the document, of course. So a couple of changes we did on the document based on feedback from the reviewers. We added certain things like making sure that when you have a port range, for instance, you have a high port greater than lower port, discontinuity timer to counters. Also, there was a suggestion that I think it was a good one. We had that regex pattern that you see on the slide spread through the document. So what we did was to create a derive type and put that regex there. And we also added the small need of having the first letter or number being one of those that you see there in the regex. I hope I didn't mess up with the regex there. Next slide, please. So a few editorial changes we did as well. We added some rationale on the intro on why we were extending IETF routing and why we had different modules. This was a comment from one of the reviewers as well. We made a note about not being maintained by IANA. We moved examples to the appendices, which I think clears up the document quite a bit. And then there was a conversation on the mailing list and also among some of the participants about geo coordinates. At the end, what we did was to add some context on why we're using the current model that we have on the document, which is basically mimicking what we have on the LCAP document, and then added a note on the privacy implication of having some geo coordinates. So next one. And yeah, we did a hopefully truthful refresh of the document. There were a lot of outdated reference, outdated dates and whatnot. So what we did was to go through the document and make sure that the references were up to date, pointing to the right RFCs. Particularly for LCAP, the reference were all over the place. So I tried to make sure that they were pointing to the final RFC number and to the right sections as well. Remove some LCAPs no longer used and no longer relevant. Yeah, and a bunch of different updates through the text that were updated, and now they are following the latest text. Yeah, and next one should be quick enough. Very small things that we did here in terms of fixing double spaces and fixing the reference to the RFC number. And maybe one thing to highlight here is that we had LISP LCAF and then LISP address type, and we converged it into LISP address type, which is LISP AT in short, through the document for the reference, but that's it. And next, just one final slide on next steps. Okay, so after this, as I said, these were long-standing comments that we had on the document that we finally have addressed. So now hopefully the plan and the chairs can comment is submit a new version, fixing a couple of very, very minor things left. If there are any other comments that you have, you can send them and we can include them as well. There is at least one pending review that I'm aware of that I'm hoping we can get. So we have an extra pair of eyes on the document. And then I wanted to submit a new version with all this and send a note to the previous reviewers so that they can check the new document and see if all the issues they had been addressed. And hopefully with that, we can go to the last call with this one that has been pending for years. So
absolutely.
And that's it.
That's a good plan. I mean, you submit a new revision, you send the email, everything goes fine, we'll go straight away to the working group last call. I mean,
sounds good. Okay.
Any comments or question, the room or online?
Good.
Fantastic.
All right, perfect.
59. We make it.
All right.
So thank you, everyone. See you in Bangkok. Ça va?